Here we want to prove that the average weight of baby girls born to moms with gestational diabetes is, and then we have three parts to this question. Let's look at the first one, is less than 3.4 kgs. Now clearly here we're not estimating the mean. So if we're not estimating the mean and we're trying to prove something, what we need to do is a hypothesis test. And when we do a hypothesis test, the most important thing to do is to set up the null, which is H, uppercase H, lowercase o, null hypothesis, and the alternative hypothesis, which is uppercase h and lowercase a, and then put the colon. Now, what we are trying to prove is always the alternative hypothesis. What are we trying to prove in question 1? We are trying to prove that the mean weight of all baby girls is less than 3.4 kilograms. What we are trying to prove is always HA. Now, HO is the null hypothesis. Again, mu equals 3.4 kilograms. So it's almost like saying everyone believes that mu is 3.4 kilograms, but we want to prove that mu is less than 3.4 kilograms. So this is how you set up your null and alternative hypothesis. So in this case, we're looking at mu equals mu naught. For the null hypothesis, we always have an equal to symbol. I'm sorry, that's a null hypothesis. The alternative hypothesis is mu less than, in this case, mu naught. So mu O is equal to 3.4 kilograms. We need to know this when we plug in numbers into the formula. Now the second one is very similar. Uppercase H, lowercase o, the null hypothesis, is mu equal to 3.4. Remember again that the null hypothesis always has an equal to symbol. Next is HA, the alternative hypothesis, mu, which is, and in this case, let's read the second question, is greater than, and what is the symbol for greater than? Greater than 3.4 kilograms. So basically we're changing the sentence to mathematical notation. That's what we're doing here. Now the last one is HO, again the null hypothesis. The alternative hypothesis HA says mu is not equal to, okay, so that's pretty clear. Mu is not equal to 3.4 kilograms. Let's make this correction. 3.4 kilograms. H naught or HO is mu equal to 3.4 kilograms. So if you notice the pattern, the H naught always has an equal to in it. Now with the HA, it could either be a less than, a greater than, or a not equal to. So when I say not equal to, that is the same as the mean being different than. So if we use the word it's not the same, it is different. The minute I say different, it's not specific. It could be less than or greater than. So what this really means is less than or greater than, which is the same as saying it's not equal to. So in each of these cases, the number that you see, let's just highlight it, the number that you see here, it's exactly the same in the null and alternative hypothesis, and that is mu mu O. So that is 3.4 kilograms. Remember that. The number that is part of the null and alternative hypothesis is mu O. Now, when we have the alternative hypothesis, when the alternative hypothesis has a less than, we do a left-tailed test. Which means we have to find the area to the left of the z statistic. When mu is greater than, then we do a right-tailed test. We find the area to the right. So this is called the right-tailed test or a right-sided test. And when it's not equal to, when the symbol that we use here in the alternative hypothesis is not equal to, then we do a two-tailed test or a two-sided test. Okay, which means we have to find the area either to the left or the right of the z statistic and double it up, multiply by 2 because it has two sides.